Okay, solutions video for Unit 9 practice test. This is part 3. How many grams of calcium nitrate is needed to prepare 120 mils of a 0.150 molar solution? Okay, 120 mils is what's given. We're asked for how many grams of calcium nitrate. Grams of calcium nitrate. When you see that grams thing right there, they're asking you to go to grams. You know you're going to need molar mass. Let's go ahead and get the molar mass of calcium nitrate. Molar mass of CaNO3 2. Okay, we've got, let's just do it over here, 1 times Ca, and we've got 2 times nitrogen, and we've got 6 times oxygen. 1 times calcium. Oh, I don't have my periodic table. 1 moment. Alright, 1 times calcium is going to be 40.08. 2 times nitrogen is 2 times 14.01. I'm just going to do the math right here instead of to save some space. So that's going to be 28.02. And 6 times oxygen is 6 times 16, which is 36, 96.00. So that's going to be 10. That's 14, 10, 16. 164.10 is your molar mass. Okay, now I'm going to solve over here. We've got 120 mils of solution. We need to know how many grams to prepare. 120 mils of solution is 0.120 liters over 1. It's a 1.5. Well, let's just do this. Let's do this first. We're going from liters to moles to grams. Yeah, so it's going to be liters down there and moles over here. All right, let's go and solve now. 0.150 moles rather. 0.150. Make sure you guys can see that. Zoom in. Okay. Per 1 liter. And our molar mass we said is 164.10. And that's grams per mole. And all we got to do is multiply. Okay, when I did the math here, I got 2.953A, so we'll just say 2.95 grams. 2.95 grams. Okay, there's your answer to that one. Okay, next up, how many mils of a 6 molar HCl solution are needed to prepare 120 mils of an 8 molar solution? Notice you've got 2 different solutions here. That's a dilution problem, you guys. How many mils of a 6 molar solution are needed to prepare a more dilute 0.8 molar solution? 120 mils. So VC, MC, VD, MD. Plug in all your numbers. 6 molar HCl solution, 6.00, 6.0 rather, M. 120 mils of a 0.8 molar solution. 120 ml of a 0.800 molar solution. Volume of concentration equals VD MD over MC. Okay, so let's plug in now. VD MD is going to be 120 mils times 0.800 molar divided by 6.0 molar. Molarity cancels, that leaves us in mils. Here's how you solve. 120 times 0.8, oops, 0.8 divided by 6 gives you 16. 16 mils of solution is what you need. Okay, number 24, complete the following table. Okay, so your concentration of OH minus, your POH in this case is going to be 1. right? Because this is what the concentration of OH minus, your POH is going to be 1. Your pH is 14 minus 1, which equals 13. That's going to be your pH. And is it acidic, basic, or neutral? It's going to be basic. Okay, your concentration of H plus is going to be 1 times 10 to the negative 13. That's your concentration of H plus. Your pH is 13. Concentration of H plus is going to be 1 times 10 to the negative 13. Okay, if your pH is 6, well, 6 is less than 7, so right off the bat we know it's acidic. Your POH is going to be 14 minus 6, which is 8. Okay, pH 6, POH 8. By the way, pH and POH need to have 2 sig figs always. That's how we report them. Okay. Okay, your concentration of H plus then is going to be 1 times 10 to the negative 6. We know our concentration, or we know our POH is 8, so 1.0 times 10 to the negative 8. Okay, last up. POH is 10. pH, therefore, is going to be 14 minus 10, which equals 4. So you got a pH of 4. That's an acid. That also tells us our concentration of H plus is 1.0 times 10 to the negative 4. Our concentration of OH minus 1.0 times 10 to the negative 10. Very simple. Now let me just say this. When you get to higher levels of chemistry, there's no way it's ever this simple. Okay, these numbers get really, really complicated, especially when you start calculating dissociation of weak acids and weak bases and things like that. But for our purposes, this is all you need to know. But you know, if you study this stuff further, you really need to understand logarithms and how they work. I purposely did not explain it in this class because I'm trying to keep things simple. All right. All right. Next up, number 25. Write the reaction of the dissociation of HF in an aqueous solution, and that's worth 2 points. Let me see if they give you. Okay, here we go. HF, is it a strong acid? No, it is not. You look on here and you go HF, HF, HF. Okay, not a strong acid. Are you going to get this on the test? You will get this on the test. That's what you're going to get, this. Okay, so HF, is it a strong acid? No, it's not. So here's how we write HF. HF dissociates like this, H plus and F minus. There you go. Draw how 5 molecules of HF may be in the aqueous solution. Okay, this is pretty fun. Some of this HF is going to stay together like this. They want 5 molecules of HF. Okay. But some of it is going to split apart into H plus and F minus. So that one split apart, and then that one split apart like that. That's all you have to do. It's that simple. I know some people were doing this type of thing too. I guess this would work, I guess. Some people were doing this. Okay, I guess that would be okay to do something like that. But really and truly, this is all you need to do. Okay, this is much easier. Consider a solution of KNO3. Write the reaction for the dissociation of KNO3 in an aqueous solution. KNO3, potassium nitrate, it's going to look like this. Potassium. Look, potassium right off the bat, you can see all of it dissociates. Okay. So potassium nitrate, here's what it looks like. Potassium nitrate, KNO3, dissociates completely. That means one arrow like that, into K plus. How do we know K is plus? Because it's a group 1 element, guys. That's why he gave you this question. That way you don't have to memorize too much. It's a group 1 element. So that tells you that nitrate, NO3, must be -1. Draw how 5 units of KNO3 may be an aqueous solution. Well, if this thing dissociates, you're not going to have any KNO3 left clumped together. It's all going to be this right here. That's what this thing tells you. That is what this means. It's saying, hey, this splits apart. That's what that means. So let's draw 5 of them. 5 units. K plus, K plus, K plus, K plus, and K plus. 5 of those. To balance that out, we've got to draw 5 NO3 units. NO3 minus, NO3 minus, NO3 minus, NO3 minus, and I'll try to squeeze one in somewhere here. How about right here? NO3 minus. Okay, that's what that looks like. And that concludes practice test unit 9.